Dear colleagues, my name is Valerij Zvaritch. I would like to present a report, some features of monitoring in diagnostic systems, technical status of hydro units. The report was prepared researcher of the Institute of Electrodynamics of the National Academy of Science of Ukraine. Hydro units are used many variable modes, which leads to an increase in the load on all elements of hydro units. It can lead to unpredictable failure of their components and even failures in the operation of the hydroelectric power plant. Therefore, the use of diagnostic system is appropriate for solving such problems. The most promising non-decreasing diagnostic systems are vibration diagnostic systems. It is necessary to take into account that a significant number of hydrogenerators are low-speed machines with a low frequency of rotation of the hydrogenerator up to 150 RPM. Such features of the machine must be taken into account when choosing a diagnostic method. A significant part of the problems related to control and diagnostic of power equipment can be considered as problems of pattern recognition in the diagnostic space. Based on assessment and with knowledge of probable process, it is possible to make remaining useful life prediction of the equipment and plan possible maintenance action based on the actual technical condition of the equipment. The main prerequisite for forecasting the remaining useful life prediction of the hydro units is the availability of information about the condition of the equipment or its components. To obtaining preliminary information, modern monitoring and diagnostic systems are equipped with smart sensors. Smart sensors provide the possibility of self-monitoring, which ensure obtaining data without abnormal values, which can be used without preprocessing to determine the state of the equipment or its units. The obtaining data are intended for use and as input data for analysis systems of means of diagnosis the technical condition of the component. The technical condition of the component depends on actual condition in which the generator operates. Actual conditions are determined with the help of additional sensors that are part of the smart sensor. As a rule, the assessment is performed by comparing the measure of the calculated states with the permissible value under which the correct operation of the equipment occurs. The structure of maintenance system, according to the actual technical condition of equipment, is represented on slide 2. To elaborate algorithm for the functioning of monitoring and diagnostic system, it's advisable to use autoregressive processes, which have become widely used during the implementation of mathematical models of information signals of various types and allow to elaborate algorithms for diagnostic technical objects that have a low frequency of shaft revolutions. The diagnostic methods is selected in the stage of evaluation of mathematical models. Usually, for example, vibration are modeled using mathematical models with continuous times. However, the majority of modern devices and information measuring systems in vibration diagnostics include microprocessors and microcomputers, and computers whose functioning algorithms are based on the digital methods of processing information system. Taking into account vibrations should be described using mathematical models with discrete types. We propose to use mathematical models of linear autoregressive processes. Linear autoregressive process is difference equation. Properties of the models are shown at slide 3. The kernel of linear autoregressive processes is recursively connected with autoregressive parameters. It is very important for development of algorithms of analysis of real data. One-dimensional characteristic function of linear autoregressive processes could be represented in Kolmogorov representation, one-dimension form, and the logarithm of one-dimensional characteristic function of all linear stationary autoregressive processes can be written in the form following. Autoregressive processes with periodic structures are also used. Such processes are the generating of the linear stationary autoregressive processes. The peculiarity of the given processes is the possibility of their use for the description of non-Gaussian periodic random signals. The properties of the processes are shown on slide 4. The processes has autoregressive parameters alternating in time with the same period is the main properties of the processes. A special experimental setup was developed at the Institute of Electrodynamics of the National Academy of Science of Ukraine. It was used for carry out practical research on vibration analysis of small machines hydro units. The main goal of the research is to experimentally identify the connection between typical defects such as misalignment, eccentricity, lack of lubrication, damage of the outer and inner ring of the bearing as a result of metal painting, and the perimeter of diagnostic signs that clearly allow the defect to be detected. Experimental setup consists of 3 main units: electrical drive, massive shaft, and vibration measurement system of testing bearing. The 11 kilowatt motors ensure rotation of tested bearing at any speed in the range from 10 to 1,500 RPM. The main purpose of the bearing assembly and vibration measurement is the ability to artificially reproduce the main defects of the bearing and the placement of primary vibration transducing equipment. To measure the vibration acceleration of the bearing under the study was used, which made it possibility to measure the vibration of bearing in the frequency band 20 Hz to 30 kilohertz. As an example of bearing misalignment time defect was modeled. Educational groups were formed in the diagnostic space R sub 1, R sub 2, R sub 1, R sub 2 are the autoregressive parameters. Two-dimensional histogram corresponding to the selected test condition are shown in slide 6. The learning algorithms and evaluation of diagnostic signs is carried out. Then, on the basis of these populations, a vector of estimates of their mathematical expectation and estimates of variance and construction of covariance matrix of correlation between diagnostic parameters and the assessment of the characteristic of the distribution of diagnostic signs were built. If necessary linear transformation of correlation matrix and normalization of correlation matrix are performed for construction effective decision rules. The algorithm is more detailed presented on the slide 8. On the slide, formulas for estimation, expectation, variance, correlation matrix of diagnostic parameters, are represented. A relation of linear transformation of correlation matrix of diagnostic features are also shown. The corresponding expressions for the likelihood radar are also presented. At the stage of planning our experiment, the threshold C and the required number of observations N are calculated. In the diagnostic mode, diagnostic sign assessed and a decision made on the technical condition of the diagnostic object based on the constructed solving rules. The proposed form of presentation of education aggregates is the relevant training blocks and the electric machine diagnosis system allow to organize the functioning of such system using SMART concept. Basic application and my email address are shown on slide 11. Thank you very much for your attention.